Okay, here we go. So y'all saw those gummy bears and other candy on fire? That's actually how they determine how many calories are in food. They light it on fire and then measure how much heat that burning thing produces. And they measure the joules of heat that are produced. And that's how many calories are in it. So joules and calories have a simple conversion. There's 4,184 calories in 1 joule. Excuse me. In Europe and all that, they actually, and what is actually on our labels, they say kcal in Europe because it's actually 1,000 calories per thing. Like when our thing says 150 calories in this little pack of cookies or whatever, that's actually, what, 150,000 calories. It's really kilocalories, kcal. So people say there's 4.184 kcal in 1 joule, but it's that means that there's 4,184 calories in 1 joule. I wanted to make sure y'all know about the temperature scales here. Fahrenheit has no rhyme or reason for. Apparently, I looked it up and I said it was complicated. Don't worry about it. It's yeah, I don't remember it because it no longer makes sense to put it there, and it's I don't know. Well, one thing about Fahrenheit is that Celsius degrees are bigger than Fahrenheit. So if you go up by 1 degree Celsius, you went up by more than 1 degree Fahrenheit. And I wonder if in Europe where they use Celsius, if when you turn up the thermostat, you can turn it up by half a degree or a quarter of a degree or a tenth of a degree or something. Because if you have to turn it up a whole degree Celsius, then you might not be able to get it just right. It might either be too hot or too cold. Because those Celsius degrees are bigger. And Celsius, as you may know, the reason why Celsius is the way it is because they made 0 degrees Celsius be the freezing point of water, and 100 degrees Celsius be the boiling point of water. So it actually has a reason for being there. Kelvin degrees are just like Celsius degrees. They're the same size degrees and everything. The only difference is they're offset. So it's no longer 0 and 100 for freezing and boiling of water. 0 degrees Kelvin is the only reason why Kelvin degrees are a thing. 0 degrees Kelvin is absolute zero. You can't get colder than that. There's no such thing as negative degrees Kelvin, because so I told you that temperature is how much the molecules are moving. If they're cold, they slow down. 0 degrees Kelvin is where they are not moving at all. And you can't get colder than that. You can't stop. You can't move less than how this is right now. They get, so like satellites with these big, very, very, very smooth, very expensive mirrors in space, they have to get them really cold because even a little bit of heat will make the molecules in that mirror vibrate, and that'll make the image slightly blurry. These things are looking really far away, and they need really clear images. So they have instruments out there, so lots of reflective stuff to reflect the sunlight from the satellite so it doesn't get warm and conduct heat to that mirror. And but yeah, even a little bit of heat will make that mirror vibrate and make it blurry. So they've got other cooling things in there too, just to keep cool. But if they get it as close to absolute zero as they can. And there's some really cold mirrors out there that are really close to absolute zero. Hello.
How's it going?
Oh.
Did you get your appreciation week?
Thank you.
Oh.
a Bluetooth.
Oh.
You should play it. Put the music on.
I don't know.
Should.
Maybe. I wonder if you could actually connect this to the computer. If they would say, don't do that. Not approved.
You do it to your phone though.
Because sometimes that's the way they do it.
If you're not a home web, that's what you use.
They gave me a Bluetooth speaker. It's appreciation week, teacher appreciation week apparently.
It's a choice.
I'm gonna do a temperature conversion example for you guys. Talk about the degrees and stuff. Where are we? Do I have one of these? I should probably just go to here. Conversion. I'll do one of these. One thing that's useful to know for these temperature scales is that 35 degrees Celsius is 95 degrees Fahrenheit. So if you're telling people it's hot, you can start there. At 95 degrees Fahrenheit is 35 degrees Celsius. So I'm going to do this 37 degrees Celsius and find out how hot that is. It's not going to be just 97 because those Celsius degrees are bigger. An increase of 1 degree Celsius is an increase of more heat than an increase of 1 degree Fahrenheit. So, where are my markers? It is possible to kind of try to do these conversions in your head. So if you start in Celsius, you multiply by 9/5, so 37 times 9, I don't know what that is. I know what 37 times 10 is 370. And if I subtract 37 from that, then I get 333. And then I divide that by 5, so 333 divided by 5, I don't know what that is. 330 divided by 5? Let's see. 30 divided by 5 is 6. 300 divided by 5 is a number. Oh man, but that'd be 60, right? So that'd be 66. Let's try it. We don't have to do mental math. We can. So if we're calculating this into Fahrenheit, we do 9/5 times 37 degrees Celsius plus 32. So we need to do multiplication and then addition. So that's why I'm doing this. So 9/5. And you can also say, instead of 9/5, you can say 1.8. But 9/5 to me, if I'm trying to do it in my head, that's more convenient. But like I said, you don't have to do that. So let's say 9/5 times 37. It's 66.6. So we were doing pretty good mental math. 66.6 degrees. I guess it's degrees. 66.6 plus 32. Do I need to use a calculator for that? Probably not. Let's see, that'd be 68.6 and that'd be 98.6. Hey, you tricked me. Oh, you made me do some kind of, wait, that's where it goes. You made me do some kind of biology here. 98.6 degrees Fahrenheit, 37 degrees Celsius. Even that makes more sense. Huh? That our natural body temperature is supposed to be 98.6. That's kind of a random number compared to 37 degrees Celsius. I mean, it's not 40 degrees Celsius or any other such rounder number, but it's not a decimal. It's 37 degrees Celsius. They probably planned that too. Anyway, that's how you do one of these temperature conversion ones. And the rest of these, one of these, the calorimeter one, you're going to have to use process of elimination. I trust you can do that because it's kind of a matching thing, right? So you'll look and see which, this was a matching section on the original paper that I did, but can't do matching real easy on Google Forms, so I put each answer choice under each question, but you'll use each answer choice only once, and I think there's some that you won't use. But anyway, try out this Thermo 3, please. We're gonna review and test soon. Because of testing, it's different for different classes, but I'll explain that more in a minute. We start this Thermo 3.